minds wide, knowledge flowing, equations on the board, numbers never sleep. Teaching math and physics while them haters count sheep. Actual education, tune in and get schooled. Flipping textbooks, breaking all the rules. From Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody?
That's dope.
Once I'm gonna probably sound correctly. There we go. Let's start the thing. Start the music. Lo-fi hip hop. What is this lo-fi hip hop? Yo, what's up, guys? Yeah, we got Reki, Shantrix, and Adarsh. Cool. And ChatGPT, ChatCCP? Dude, this is fucking hilarious, dude. What? Oh, man. Okay, let me take that off. Sorry, a couple of housekeeping things. That's still not loading? Why? Ooh, good. We're not getting as much render lag today. I'm happy about this. Nice. Okay. And then let me share my screen here for you guys so you can see. There we go. What's up, Regan? Good to see you, dude. All right, nice. There we go. Awesome. I was actually messing around just before this with some kind of like local AI models that you can use to generate images of pretty much anything. So ChatGPT has limitations on what you're allowed to generate, obviously. But apparently there are, because I've always wondered, I'm like, how are people doing these funny images of like Taylor Swift or like Kanye West or something? I'm like, how are you doing this? Because I know ChatGPT doesn't let you do that. It turns out they're running the models locally on their own computer. So one of my friends is like, he's a pretty cool guy. He's a PhD from MIT. He's working in San Francisco now. He's like, yo, let me. He's like, go download these files. Let me show you how this works. And so I was just working on that with him. What's up, Smog? Good to see you, Smog. Professor Gold, yeah. And we almost got it working, and then my GPU was like overheating. And I was like, I have to start the stream. So I abandoned the efforts on that. But I will try it out later. So it could be kind of fun. Could do some things where I don't know, you can get AI to like generate basically whatever you want. There's a lot of restrictions. Like ChatGPT doesn't let you generate images of anything. Of everything, sorry. How have I been? I've been good, dude. A little busy, as always. I mean, California's been crazy. We had the fires midway through January, and then we have all the election stuff happening, and now the presidency is something new every day. There's a lot of stuff going on, but I'm okay. I'm not burnt. I'm alive. What GP do I got? I have here. Let's see if this works actually. I think you do ! specs. There you go. Nice, 30 stream streak. Good job, guys. Yeah, if you want to see what I have, because I know a lot of streamers have this. Oh, I have to click on the green human to continue. What is this? Okay, whatever. There you go. These are my stats. So, where does it say? Where does it say stuff? Oh, there you go. Yeah, 5800 X3D. I got 2 video cards because I have to run like 5 monitors. So I got a 3070 Ti. This is my main one. And then I also have this piece of shit AMD whatever. But that just runs like my extra 2 monitors. And 32 gigs of RAM. Wow, Sam. Thank you, dude. What's up, Sam? I'll drink the rest of this protein shake for you. Nice. How's your voting, Sam? How's voting in the German elections for you? Did they make it easy or was it difficult? Oh, thanks, Smog. I appreciate that. This month is a 2x XP event for who? What is the 2x XP? What's being 2x XP'd right now? Double XP? Double XP in what? In COD? The other thing I've been like kind of working on, just like, you know, keep you guys a little updated with things I do in life. I got a one wheel from this 7th grade kid who was selling it for pretty cheap. And I immediately started tearing it apart. So this is what it looks like. It's called a Pint X. It's a pretty cool board. I used to have a Pint and then someone stole it. So I was upset about that. So, but I found this one kind of used on Facebook for like half the price from some 7th grade kid who wanted to get into like mountain biking. So I was like, sure, I'll buy it instantly. So yeah, so I bought this thing and now I've been tearing it apart because it's obviously been used. There's like dirt and stuff on it that I'd rather just like kind of clean up. But then the main thing is there's actually a well-known bug in this thing where, yeah, if you eventually get to like the battery pack and stuff, that's my pizza. There you go. This is when you start like opening up the harnesses and things. If you look right here, so this is a big battery. This is a massive battery that powers the whole board. And then these are called the balancing wires. So these keep the battery cells balanced. This is a chemistry thing actually. We can talk about it later. But in general, in order for the battery to work, it needs a chip to like keep the cells happy. And this cord right here, this series of cords, gets pinched inside the plastic housing because when the manufacturers made this, and it's a well-known error, and they refuse to acknowledge it that it's an error, but over time, this will eventually cut through, which is bad because then the batteries catch fire. So this is not a bug, it's a feature. Yeah. So it's not a scam. No, it's not a scam. It's just, you know, companies do this, man. Like, they make mistakes when they do stuff, and then they just refuse to acknowledge it because they don't want to deal with it. So actually, it turns out if you contact the company, you can ship this back, and they will fix it. But they don't publicly advertise that because they don't want everyone shipping their boards back in. They don't want a huge recall. The issue here is I bought this used, so I'm not sure they would, like, you know, accept my warranty for it. And the second I start opening up things, you start voiding warranties anyways. I'm a big void warranty person. I love just tearing shit apart. I'm like, I'll figure it out. So yeah, so this is something, I got to Dremel some stuff out, put some liquid electrical tape and make this safer. And then the other thing I got to fix on it is inside the board. I got to replace, you can actually see there's already like dust and dirt in here. That's crazy, man. But I got to replace this port because I kind of accidentally broke it while I was opening it. Oopsies. Can you tell me how to get points? I forget. There's a whole channel for this, Regan. It's called How to Get Prizes. There you go. A whole channel for it. Anyways. Yeah. Reki, are you still trying to get banned, bro, from doing too many emojis, dude? Yeah. Yeah. Don't be mean to it. Anyways, yeah, so cool. That's what's going on. It's Tuesday. I fly out to Philly on Thursday, so we got this stream and we got tomorrow's stream, but then no AMA stream on Friday, and I will play video games with you guys. I swear I will. I can't do it this weekend. I'm in Philadelphia this weekend. Maybe the next weekend, but that's Valentine's Day weekend too, so I don't know. A lot of things going on. Anyways, Y'all let me know what happened in the last day or so. Anything cool? Did you learn anything new in school? Did anybody? Oh, I like to say, yeah. What's? Do you have anything you're looking forward to at the end of the week? It's a 3-day weekend for some people next weekend because it's President's Day in the U.S. So that'll be fun. Let's see.
Yeah, wait, Sam, aren't you a mod? Like, wait, does Nightbot still gets mad at you as well? Anyways, yeah, oh, you have a new semester starting tomorrow. That's really cool. Sweet. New semester, new time to... Isn't President's... It is, yeah, so I'm not saying... So not this weekend, Jeff, but the next weekend. The next weekend is a 3-day weekend. Yeah.
This weekend coming up is the Super Bowl. So for people in the U.S., this is basically a holiday, like, weekend. Music instead of art. That's fun. When I was in 5th and 6th grade, we got to pick music or art. So we did one or the other. I ended up doing orchestra and then became a cellist, and that's why. Fuck the Chiefs. I agree. Yeah, go Birds. I've been kind of recently adopted by my neighbors who are huge Eagles fans. And actually, you may know them. A-Rod is one of them. He used to play a lot of video games with us back in the beginning of this server. Back like 2021, 2022. I think Sam's played with A-Rod. Yeah. Yeah. So, yeah, this was me going in my Eagles gear to go watch the last game. It was the championship before the Super Bowl with Alex. And there's probably a video of us. Yeah, here we go. This is the video. This is Alex. He has a song called it used to be for Jesus Christ, but now it's Eagles Sunday. So this was us going over, watching the game, and he started playing his little theme song. It was cute. What's up, Reki? You're back. This dog is adorable. Okay. All right. A-Rod, yeah. That being said, let's start the stream off, get you guys some help with the homework and stuff, and we can always chat around about other stuff as we do it. Okay, cool. All right. And with that, let's start off the stream. Welcome everyone to Office Hours. My name's Dr. Cole, Sex Education, streaming helps you math, homework, science homework, all the fun stuff. Get my webcam working. Oh, you know what it is? Oh, I gotta reconnect one thing. I gotta be careful though which cord it is. Ooh. It is, I want to say it's this one. Oh, good. It is. Yeah, because if I pick the wrong cord, it'll mess up my whole setup. Okay, there we go. There we go. Now I'm back. Yeah. Yeah, Reki, chill on it. Okay, cool. All right, let's see. This looks like a fun challenge problem. Number 24. This is guaranteed to be a little tricky, right? We're gonna turn the. You tell me if the jazz music is like too much. We'll turn it back off. Oh, also, is my. It's still not working, dude. YouTube is the worst. Okay, quadrilateral, A, B, C, D. Okay, so we have to draw a quadrilateral. And I see that there are two 90-degree angles. Okay. So, let me think. Let's call this A, B, C, D. And I know that BCD, which is this. BCD is also the name of one of my favorite, and Bond's favorite, late night Korean not Korean barbecue, sorry. It's like just Korean, like, drunk food, I guess is what it is. But okay, so BCD is 90 degrees and DAB is 90 degrees. Interesting. Okay, so we know these two are 90. Now, wait a minute. I wrote D backwards? Whatever. Jeff, what's up?
My man.
I didn't write D as well as I should have, honestly, yeah. It's grade 11, so it's extra hard. Uh-oh.
Obviously, don't go and do that, please.
You do whatever you
It's gonna be
like.
very
But
difficult
we
here.
can't condone anything of the sort.
We can't live.
Okay. BCD is 90. DAB is 90. Is there any way these cannot be 90? Oh, actually, I see how this can work, actually. Uh-huh. Okay, one sec. Let's redraw some stuff. I think you can do this. You can have like a kite. I think this is called a kite, isn't it? It's called a kite. Well, here, let me make the angles the same. Let's make this one. Whatever. Make this like 60. We'll make this like 30. Okay, cool. And we'll call this BCD. And then, I don't know, we could have whatever here, I guess. Well. I'm trying to think how you do this. Sorry, what? Okay. These have to be 90, right? Doesn't it kind of imply the other ones will have to be 90? Well, they have to add up to 180, though, right? Kite has two sets of equal sides, but you don't know any sides are equal to each other. Yeah, the sum is 180. I'm just trying to think how that works. I guess you could do this. Let me just for my sanity. I just want to see. A, B, C, D. And we know that this is 90. This is 90. So the opposite sides have to be 90. So this is A. This is B. This is D. Okay. I noted. Yeah, they have to just be opposite lengths. That's what it is. Okay. All right, you could have this. Whatever. Let's just say something like that. Just work with me on this. Well, I feel like I'm just gonna always get it being 90 and 90. How do you do it not to do that? Oh fuck. Whatever. Okay, thank you, Endar. Endar is making me okay. Draw 30, 60, 90 on top of one another with a shared hypotenuse. Thank you. Okay. All right. 30, 60, 90. Here, we can actually literally draw it. Thank you. Okay. Okay. I was losing my mind there, dude. And actually, you know what? This has to, like, cut down, doesn't it? Here, we're going to use some aids to make this. Some visual aids. Okay, cool. There we go. That's what I wanted. Which to me looks like a kite, right? Okay. This is 90. This is 90. Yeah, geometry like bugs me out sometimes, dude. It's the weirdest math, right? I don't think it has to be a rectangle. I hate geometry. I had a really good geometry teacher. Rest his soul. He died of brain cancer like a couple years later, but he was a super dope guy. And it is really important to have a good teacher for things. For sure. Okay, B, C, D. And then this will be A. Okay, cool. So now these things are satisfied. Good. Okay, the perimeter of ABCD is 224 and its area is 2205. One side of ABCD has a length of 7. Just one of the sides. The remaining 3 sides have integer lengths. The sum of the squares of the sides of the length is S. What is the integer formed by the rightmost 2 digits of S? Bro, they're just like, oh my god, dude, what? Oh no, dude.
Oh no!
This is very difficult.
Oh.
This is gonna be a tricky one. There's so many things going on. Okay. Like, is this just meant to bug you out, or is there some property about the last 2 digits doing something? You know what I'm saying? Okay. Let's start labeling some things, right? Let's label this X, Y, Z. Well, W, X, Y, Z maybe? Yeah, let's do that. Let's say X, Y, Z, W. Okay, so W plus X plus Y plus Z, that has to equal to 224. And its area, Okay. I kind of want to take... the idea of that this I'm going to call like... Actually, no. No, fuck that. No, we're good. We have a base and a height, right? Okay. The area, right? Area is equal to 1/2 XY plus 1/2 YZ. I think that really helped. I'm going to give Endar a save for that. I appreciate Endar for you saying the 30, 60, 90s together. It really, like, saved my sanity here. Okay. Cool. That needs to be equal to 2205. All right. One side has a length of 7. Just one. And then the sum of the squares of the sides is S. So W squared plus X squared plus Y squared plus Z squared is equal to S. And then they want the integer formed by the rightmost 2 digits of S. Algebra is definitely used in geometry. Geometry is definitely used in like calculus and stuff too. So. Okay, let's see. One of the sides is 7. That's all I know. Okay. Who's gonna go in real life and say, what's that angle? What's the shape of it? Oh, they definitely do for sure. Geometry is very important. You know, the classic question of if there's like something here, there's a tree or whatever, and then there's a shadow. It's really cool to know how the shadow and the angle can then tell you the height of the tree. It gets used. Geometry gets used a lot. That's pretty cool. Engineers, exactly. Yeah, engineers use it. It's always good to just keep your options open, you know? That's what I say to all the kids. When you're learning stuff, you're like, why am I going to use this? Be like, just know it anyways, because you might use it later. And if you know it, it allows you to go into that field later. You nerd. Yeah, Chantrix is a very smart person. Yeah, Chantrix is good. People like different things. I'm a nerd. Nerds are great. Yeah. Okay. Something has to do with this side length being 7. I feel like these triangles have to always be the same. I feel like this has to equal this, and this has to equal this. I'm trying to imagine a situation where they don't. Because if I make this longer, right, then I would change this angle. Oh, maybe not, though. Well, one sec. Could you... Let me just, like, for shits and giggles here. If I were to say, for instance, like, move this back here... Oh, okay. Well, no. Right? This would still have to be 90 degrees. I agree. Yeah. Okay. I'm going to go on a limb here. And I believe that these two triangles are similar. I think I'm allowed to say that. So I'm instead of defining the area this way, I'm going to say, like, let's assume that W is equal to X y is equal to z. I'm not sure rigorously how I prove that. I do know this is the same angle. It's the same side. Side angle side would be nice, right? Yeah, but don't assume anything not given in the question, but I'm pretty sure these have to equal each other. I can't visualize a way that they couldn't. Right? I feel like in order for this to be 90, in order for this to be 90, in order for them to like intersect, right? Because that's what you're doing, right? You're taking two right triangles, and they have to meet up. Rainey says, I think there's a geometry rule that says I'm correct. I know. There's some fucking obscure rule here about kites and stuff. Actually, let's just look up the formal definition. Wait a second. We want quadrilaterals. That's a rhombus. Yeah, no, I feel you. Yeah, I feel like they have to. I don't know the exact proof why, Shantrix. But I'm getting a feeling they have to. And honestly, on these math competitions, they don't care for the proof. They just want to know if you get the right answer. So okay. For now, like if you're taking a math competition, you have to start making some assumptions. Otherwise, it's gonna go bad. All right. So let's assume that they're the same. Okay. So then our area, which is just, this is going to be the same thing as this. So we're going to say that XY is equal to 2205. And that, good. And then now our perimeter gets a little bit simpler, right? Because now we just need the perimeter of this and double it. So we know that 2x plus y is equal to 224. So x plus y is equal to 112. Nice. I like this already. This is already nice. Okay, so if xy is equal to 2205... icosahedron. I don't know this. Okay, then x plus y is equal to 112. And we know one of the sides has to be 7. Well, here's the interesting thing. Okay. If this is 7, right? Then this has to be 105. Right? Oh, man. But then that doesn't work here. Because if this is 7... now they can't be equal? Is that what we're saying here? Because everything has to be integers. Well, first of all, it just doesn't even work here. Where's our boy Sensation? What's up, Pen? I hope you're having a better day today. Hope today is full of joy and love and butterflies and... I think the The tariffs got extended 30 days. Shout out to Penn Center. He's a great person. Streaming math and science, or mainly, sorry, just math. You do try some science sometimes. We need to get you another go at the physics stuff. Yeah, I'll have to reach out to Sensation. I haven't seen him in a bit. Or I haven't seen him this week. We saw him last week. Maybe he's out on vacay. Yeah, cracked a whiskey by 10. Never too early, dude. It's, you know, it's at least 5 p.m. in Ireland at that point. Yeah. I don't think 2205 divides by 7, bro. Does it? Oh, it does. It's 315. Oh, okay. Terrible union day. My deans are assigning grades to students. Yeah, this is... I'm not looking forward to this if I teach this pre-med class, because grades are everything to those groups of people. Pre-meds are people that are going to college with the intention of going to medical school. And so they tend to take special classes made for med students. And so, for instance, there's a physics for med students that doesn't use as much calculus to teach it. It's more like algebra based. Whereas there's what's called like physics for engineers, and that uses calculus, which makes sense. Like physics needs calculus. Calculus was invented for physics. And I'm not looking forward to unions. Yeah, unions suck. Okay, first of all, is this perimeter really 224? Okay, so we've kind of proven something to ourselves, which is that I can't assume this. No. Because if I do, then my area, right, if one of these has to be 7, means that the other side has to be 315, but that doesn't satisfy the perimeter. So this is wrong. We can't assume that this side equals this side and that this side equals this side. Damn. That's unfortunate. I'm sad.
Oh, no.
Can't do that. Sad day. Coral. Maybe equal in ratio. Yeah. So here would be my... Because Endar had us start this, right? With a 90-degree angle and a shared side on both. And I think he's still okay for this. Oh, I see what could happen here. Watch this, guys. It's actually pretty cool. Let's say this went out like this. And then this went out like this. So that it's 90, right? Yeah, watch what happens. Let's do it. This is the beauty of it. This is why I love having an online thing. Like a drawing board here that I can do stuff with. Yeah, okay, cool. Because I think this is the case. I think now this line gets extended. Uh-huh. Okay, now we're getting somewhere. Starting to see it. Starting to see the matrix, dude. Okay. Wait. Are those not the same length, though? Are they not the same length? I feel like they have to be. Can't this... Doesn't this have to be the same length as this now? Damn it. BCD is 90. BAB is 90. Perimeter is 224. XYZ. XYZ. WXYZ, yeah. Okay, Shantrix, I need a hint. I've been banging my head against this for like 10 minutes. Can X equal Z? I kind of like that, D's. Yeah, let's try that. So you're saying what if I just like extended the length of this thing out like a lot? Here, let's do it. Let's just move it. And move things around. All right, construction. You're saying if we extended this out and then made... I don't think it can though, man, because this has to be 90. Oh, okay. Whoa. Maybe we can rotate this, right? Yeah, okay, what if we do this? Something like this, I guess, right? Or this is now 90. I guess that, yeah, that looks pretty weird. It's pretty funky. This is 90, this is 90. Now I've messed up all my lines, though. If x were equal to z. Sorry, let's just see something else here. Let's do this. All right, let's just have these equal to each other. We're gonna say that x is equal to z. But then I need a 90 degree here and a 90 degree here to connect them. And I think the only way for that to happen is for this to be a rectangle. Right? Because that's basically what we're saying. If this is D, A, B, C, DAB, and... what was the other angle? Wait, DAB and BCD. Wait. Oh. DAB. Oh, BCD. Oh, so they're not opposite angles. Wait. Oh, no. They are. This is DAB. This has to be 90 degrees. And this has to be 90 degrees. Okay, I mean, this is the hint. The hint is like what I kind of just already drew. Let's see. Maybe I'm just like missing something. Could happen. Okay. Okay, this is a case where this does not equal this. All right. Kind of starting to look a little better. Okay. Okay, cool. These formulas still hold. So they called this W, basically. They said W equals 7. Okay. The cool thing is we know everything else has to be an integer, right? So this squared plus this squared has to equal... well, this doesn't necessarily have to be an integer. But I assume it would have to be. Right? Because this squared plus this squared must equal something. What is there's some theorem thing. What was it called, guys, where where things have to be integers? Okay, here. X plus Y plus, let's substitute W for 7. Has to equal to 217. And then that means that 1/2 XY plus 7/2 Z has to equal to 2205. What's up, family? Trying to do this math challenging math question. It's a geometry puzzle. Geometry is the bane of my existence. Okay. And then also that W squared plus X squared plus Y squared plus Z squared is equal to S. Are you okay, Wonka? Yeah, it's not bad. It's actually one of my favorite physics books. John Coley. It's a good one. Okay, interesting. Okay, but if I sub this into here, okay, now I know that X squared plus Y squared plus Z squared must be equal to S minus W squared. And if this is an integer and this is an integer, this must also be an integer. Okay, so I need like some Pythagorean theorem thing for 3 variables. It's not a Pythagorean triple, it's like a Pythagorean like quadruple. Okay, here's the other cool thing. This side plus this side squared must equal this side plus this side squared, because they both form right triangles. Okay. So we can also say that 49 plus x squared has to equal z squared plus y squared. Okay. Getting closer. Oh, ooh, bingo. See this? That's nice. I like this. I'm a fan of this. This is this. So, we can say that x squared plus 49 plus x squared has to equal s minus w squared. So, yeah, that's pretty cool, isn't it? Okay, so 49 plus 2x squared has to equal s minus w squared. Oh, wait, we already have w squared. W7. Right? X squared plus y squared plus z squared. Oh, very cool. Wait, whoa. W squared is just 49. I'm dumb. Okay. Oh, so now we have a solution. So 98 plus 2x squared equals s. All we need is x now. I don't want to use trig. I don't think we need to. I think we need to use something with this and this. Something here. I'm tempted because I see cross terms here to do something with this. Yeah, I don't think I want to use sine and cosine or stuff though. Except I do know that this angle and this angle must add up to 180 degrees. Oh, I can use trig because it's grade 11? Sure. There's something with this. This, I need to use this somehow. Okay. Let us say that z is equal to 217. You're good, Rainy. Good to see you, Rainy. Alright, 217 minus x minus y. That's equal to z. If I plug that into here, first of all, let's multiply everything through by 2, because I don't like fractions on things. So this is going to be that xy plus 7z equals 4410. Now, I'm going to replace z here with this. I'm going to say that xy plus 7, 217 minus x minus y is equal to 4410. What's 7 times 217? Seven times 217 is 1519, and let's move that on the other side. Let's do the 4410 minus that. 2891. Okay. So xy minus 7x minus 7y is equal to 2891. I don't think that divides by 7, does it? It does. Ooh. Okay. xy over 7 minus x minus y is equal to 413. Okay. So x times y has to be some multiple of 7. Because I need all of these things to stay as integers. Right? I wonder if I can decompose this one. Let's group this with this, and then let's pull out a y. So I'm going to say y x over 7 minus 1 is equal to 413 plus x. And then I'm going to move this underneath. I'm going to say that y is equal to 413 plus x over 7 minus 1. So this is x minus 7 over 7. X has to be greater than 7. That tells me that. That's cool. Right? Because y can't be negative. So x must be greater than 7. Okay, now I need something with... Yeah, what's the other hint? Let me see the other hint. Okay, so we got the 4410. That's cool. Mm-hmm. They multiply it through. Yeah, I get to this step. All right, cool. We're cool. And then what do they do? They pull an X out. All right, let's see how this works. That's kind of clever. Let's try that. They pull an X out of these two. Oh, y minus 7. Minus 7y. Equals 20. Oh. This is very cool. Almost like a completing the square trick. And actually, I was talking to Pen Center about this. Remember, weren't we doing this, Pen? You're just adding 0. It makes things easier. So what I want to do is I want to make this have also y minus 7. Because then that'll be two factors multiplying by each other. The only way to get that is for us to have this has to be plus 49, and then if we add 49 here, we also have to add 49 over here. Because now what happens is I can rewrite this part as minus 7, and then this is going to be y minus 7. Do you see how minus 7y, minus 7y, minus 7 times minus 7 is plus 49? Very cool. Okay. This is the trick. Wow. Okay, cool. So now, yes, I get x minus 7, y minus 7 must be equal to, what is that? 2930? 2940. Yeah. Bingo. Okay, cool. Now, there's some property about this with integers, I remember. Right. What is this theorem called? Some theorem, Oh, hilarious. If I type in this, it shows. Oh, it shows. That's cool. This is our dude. Look at this. Look, our ad is showing. Isn't that cool? Google has our ad showing. That's pretty dope. Okay. I'm not even paying for that. Do it normally first. Oh. Yeah, you're. Oh, that one. Oh, that's a different question. Is it the fundamental theorem of arithmetic? What is this theorem I'm thinking about? There's some. It's a math trick I should know. That if these have to be integers. Well, first of all, x and y have to be greater than 7. At least. They have it with y and z. I don't really care about y and z. Okay, Shantrix, what do I do once I have this? Is there another set of interesting things here that happen? Quam. What's up, Quam? Yeah, you know where to do it. Join. It's in our Discord. If you do things in our Discord, in this channel. Oh, it's showing the wrong channel now. Damn it. Ugh. Anyways, there's a channel called Help Screenshots that has it. Okay, here we go. Here's the next hint. Yes. Okay. So x minus form a positive divisor pair of 29 and 40. They're either both positive or both negative. Since they're positive, if both of them are negative, dude, Jesus. Bro, what? Uh-huh. Oh, okay. They both have to be positive. But even if they were 0, for instance, right? Say this was 0 and this was 0, you'd still only get 49, which doesn't work. Right? Also, yeah, there's no way to get up to 2940, right? Y plus Z equals 217 minus X. Where do we get that? Oh, okay. No, we did have that over here. So Y plus Z must be less than 217. Uh-huh. Okay. Okay. Well, I have X plus Y. X, yeah, okay. X plus Y must be less than 217. Cool, I agree with that. And then these added to each other must be less than 203 since 2940. Yeah, my Discord is one big screen. What do you mean? I don't know what that means, Quam. Okay. Here, I'm gonna pass on this question real quick, just because this is getting ridiculous. I don't want to do this anymore.
What the
this-
fuck is this piece of shit?
Yeah. Try to not give me grade 11 questions for this. This is nuts. I'm not doing this anymore. I'll still give you credit, but once they started talking about like all these combinations and shit, I'm like, I'm out. Peace. Yeah. Oh, let me customize your experience. Yeah, you just click on the things and stuff. That's all you gotta do. Yeah, no, bro. Okay, Shantrix, you should know better than this, dog. Don't give me questions where the solution is this. This is insane. I'm not doing this. I'm not gonna test all these cases, especially not on a stream. This would take forever. There is a second solution. Well, the second solution is much nicer. Yeah, okay. All right. At least this is better. Yeah, okay. Yeah. I don't think I was still gonna get this. Yeah, you could have squared both sides. Rearranging and squaring the first equation and using the second and third equations. Yeah, it's just ugly. It's a cool technique. I'll still give you credit for it, Shantrix, but kind of hurts my soul. Yo, what's up, Don?
Perfect.
Don, we were doing some ridiculously difficult geometry questions. What's up, Fembox? Yeah. This was the grade 11 Waterloo challenge, I think is what it was. But yeah, shout out to Don. Boy Don. Yeah, Quam, you can paste in the chat. I gave it to you twice? Did I give it to you twice? Oh, I did. Well, I can't tell because your brother keeps fucking spamming the Discord chat. Yeah, chill, Reki, dude, on the Discord chat. Otherwise, I'll take one of your bond coins and give it to your brother. Reki, you're gonna give one bond coin to Shantrix if I can't keep up with like what's happening in the chat. Some guy in my class got first in all of Canada in grade 12 Waterloo math contest. Wow. Good for him, dude. Yeah, this is not a very easy geometry question, Don. Well, it was I was cool with like setting up the equations, but then oh, sorry, it's the fucking Fermat challenge. Okay. Yeah. But yeah, the solution was just pain. This is such a painful solution to do. I was like, yeah, no. Good for you if you can do it. You get cookies. All right. Let's see. Let me help out someone else. Is Regan still here? Or did Regan leave? Regan, did you need help with one of you? Because you haven't asked a question in a while, Regan. No, I don't think he is here. Is he not? Yeah. Again, I can't tell in the chat because too many things going on in the chat. Shandrix, did you help Regan? Did he still need help? Oh, there you are. Yeah, what's up, Regan? Yeah, do you want help? Okay, let's do it. All right, cool. I think this is pretty chill math. I can paste that in Overleaf. Find a pair of positive rational numbers such that okay, cool. Don't you just solve it, make it positive? Well, that's kind of hard to do when this is 0. I think the general trick you do. Wait a minute. There's only one solution to these, bro. What? There's not 2. Yes, right. If it wasn't 0, there would be 2 solutions. You can just get rid of this, I feel like. You don't even need this. If it's equal to 0. If instead you had this, let's say x plus 3 was equal to 5, okay? You have to solve this 2 ways. You have to do it the regular way, just, you know, strip off the absolute values. So this is just x plus 3 is equal to 5. And then you can either make this negative, this side negative, or make the whole thing inside here negative. I tend to like to make this whole thing inside here negative. So I would say negative x minus 3 is equal to 5. And then you solve both of these. So in this case, x is just equal to 2. And in this case, you get x is equal to negative 8. Yeah. It's pretty easy. Yeah. Because these are all equal to 0, you don't need to do this trick. You can just literally just put in whatever like sets it equal to 0. Yeah, you just subtract 2. Yeah. Negative 0 equals 0. Yeah. Negative 0 does equal 0. If 0 is allowed to be negative. Regan. Yeah. 0 can't be negative. I mean, probably not properly, but yeah. I mean, negative 0 is 0, I guess. Yeah. Okay, Regan, does that make sense to you? It's not that bad, right? This is so much easier than the other question I was just going through. Yeah? Okay, cool. Great. Good job. All right.
Well done! Well done!
Okay, let me post that, and then... Let me see. Let me get Qualms real quick. In Overleaf, I could put this in this. So if anybody wants to know like how to like quickly do LaTeX online, I love this website. It's It's called Lagrita Text Editor. Jesus, what are these ads? But this is super useful. So here's what I'm gonna do. I'm gonna say, and I'm gonna put this in a text. There are a lot of ads on this, I will say. There. And then here we'll do. Yeah, I don't know what big skip is. Whatever. Okay, I think it's this. And then here, let's decrease the size of this. Let's make this like 30. Is this the question? Quam? I'm going to put this after Recce's. Or I'll do Ace as well. Ace hasn't been here yet, but... Yeah, that's it. Find a pair of pair of positive rationals such that is true. Okay. Someone take a screenshot of that if you want to do this on the side while I help out Recce. Okay, but here, let's do yours, Recce. Okay, this looks like stats. Grace's favorite activities are going to the movies and skating with friends. How wholesome. Good job, Grace. She budgets herself no more than $75 a month for entertainment and transportation. Movie admission is $9 per movie. Skating is $5. A student bus pass for the month costs that. Define the variables and write a linear inequality to represent the situation. This is cool. So this is like taking word problems and converting them into math equations or math expressions. A lot of you guys ask me, like, why do I learn math? Why do I learn these things? It's because shit in the real world, like, can be converted into equations. In this case, Grace is trying to make sure she don't go into debt. So she has to use math to figure out how many times she can go watch movies and go skating. Yeah, that's where math can be handy. Okay. Define the variables. Okay. I would call a variable like X and Y. And I would say X is the number of movies she goes to watch, right? And Y is the number of, like, skating. Because that's... When we want to, like, define the variables, we want the things that are unknown. What's unknown is how many movies Grace is going to binge this month and how many times she's going to go skating. Everything else is kind of known. We know she needs to buy a student bus pass for a month. And we know that her budget is $75. Okay. Okay, so then to write an inequality to represent the situation. Okay. Well, the total amount of money she's going to spend, right, is going to be 9x, because it's $9 per time she goes to the movies, plus 5y. And this also needs to include a $25 bus pass. So we're going to say plus 25. So these are her monthly costs. And this has to be less than... So it says no more than 75. So I think less than or equal to 75 is okay. Great. Okay. So now you can move this over. This is where, like, you can start doing math stuff, right? We can subtract 25 on both sides. And we get 9x plus 5y is less than or equal to 50. Okay, cool. What are the restrictions on the variables? Okay, what are the restrictions, Recce? Restrictions means kind of like asking what's the domain of each variable, like what we're allowed to do. Five and 1. Zur or zoo? What the fuck is that? Are those pronouns? Oh, X is all real. Oh, are you talking about this? You talking about this? Sorry, I thought you were like coming up with some weird pronouns. X is an element of real numbers. Okay, good. All right. Well, I don't know if you were saying like Zimzer or something, dude. This is what this kind of looked like to me. X is a real element of W. What is W? Is W all the integers? Oh, whole numbers. That's what it is. Okay, cool. Yeah, whole numbers. Thanks, Endar. Well, X cannot be all real numbers, Recce. It does definitely need to be an integer, right? You can't have half a movie. Unless, I guess, you walk out of the movie because it, like, sucks. But you don't get your money back, usually. You know, you can't buy half a movie. So they do have to be integers. But she can't watch unlimited movies. Why not? There's a top end on the number of movies she's allowed to watch. She can't watch more than 5. Yeah, I agree. Yeah. So yeah, if you look at this, right? if she went skating 0 times, she's like, I'm not going to touch grass, ice. I'm not going to do any of that. You would then have 9x is less than or equal to 50. And the biggest integer you can put in for x here is going to be 5. Because if you put in 6, you get 54, and that's too much money. Okay. So, yeah, we know x must be less than or equal to 5. And by the same token, we know that y must be less than or equal to 10, right? Because if she decides to watch no movies, then she can only go skating 10 times. And Shandrix is also right. These also have to be greater than or equal to 0. Because you can't go watch a movie negative times or go skating negative times. Okay, cool. All right. Those are restrictions. Graph the linear inequality. Use your graph to determine a combination of activities that Grace can afford and still have some money left over. A combination of activities she can afford with no money left over. And a combination of activities that will exceed her budget. This is very cool. I like this, actually. Okay. And this is cool. I mean, this is you will use this when you do things in, like, life and, like, analyzing data. This happens all the time. If I rearrange this into the equation of a line, I can move the 9x over. So I have 5y is less than or equal to 50 minus 9x. We can divide by 5. And I have y is less than or equal to 9/5 x plus 10. This is going to be, yeah, you don't really use it in stats, but like in physics, for instance, I definitely use this. This is a data analysis thing. So let me just graph that. We have Desmos. I can use Desmos somewhere. Where's Desmos? Okay, there we go. Graphing calculator. Okay. So we can say 9/5x plus 10. And then let's zoom this out a bit. Yeah, that's what I want to see. Good. Okay, cool. Okay, so this is what the graph would look like. Now, when you want to figure out like what's shaded, see how there's like a less than here? There are two places this could be shaded, right? This could be shaded here, or it could be shaded on this side of the line. The way to test this, it is down. I know it's down because of this, but if you ever get confused which one it is, always just test a point on either side of the line. So in this case, I'm just going to test 0, 0 and see if that statement is true. So if I plug in 0, 0, which means this is 0 and this is 0, I get that 0 is less than or equal to 10. Is that a true statement? Yes.
Nice.
It is. So that means that's where we shade. This will come in more handy when we do, for instance, like parabolas, and you're trying to figure out, do I shade here or do I shade here? It's the same thing. You pick points on the inside or the outside or whatnot, and it figures it out. Okay. So we already know, right, that she can't go to the movies negative times. She can't skate negative times. So everything has to be in quadrant 1. And we know that this are the acceptable things she can do. Now, if she's not equal to the line, then that means she hasn't used all the money yet. So we would say that the pink shaded area here, that represents all the activities she can do and still have money left over. The green dashed line is all the things she can do and have no money left over, because that's when her spending is exactly equal to the amount. Yeah. Yeah. Whenever the equals is satisfied here, that means that this is equal. But that's not really possible. I don't see any integers that works for. So you could say this right here, that there is no integer quantity of things that she could do and have no money left over. Unless she goes to the movie 0 times and goes skating 10 times. That's the only time that there's an integer amount that equals it. And then the activities and 5, 1. Oh, you are right, actually. 5 and 1. Is that true? Yes. Okay. Thanks, Endar. Endar's right as well. Yeah, if this was 5 and then this was 1, you would get... Okay, so there's actually 2 places that happens. Good call there. Good eye there, Endar. You get a save as well. Nice, Endar. Yeah, okay. Pre-fired that. You did, Quam. Okay. And then the things that exceed her budget, Reki, that's going to be these. Okay, cool. Nice. Good job. Great question.
Well done! Well done!
Okay. Let's see. Let me take a quick look at Quam's. And then, I don't think, Ace, you've asked a question in a while, so I'll do yours, and then I'll do a Darsh's. And then I'll do... I feel bad 1K had to leave early. Yeah, let me know if you have to leave early. And if you haven't asked a question on the stream recently, I'll go through yours first. Just to make things fair. Because I know not everyone wakes up early in the morning to submit questions. Okay. Let me see if I can do this for you, Quam. Find a pair of positive rationals such that this is true. Jesus Christ. Huh. Well. My first inkling, I don't like seeing radicals on the bottom. So I'm going to do what's called rationalizing this. And I'm going to multiply the top and bottom by what's called the conjugate. So I'm going to multiply this by the 4th root of 5 plus 1. Multiply this by the 4th root of 5 plus 1. On both the top and bottom for this. That's going to turn this into an a squared minus b squared situation. So we're going to have the 5th root of 2 plus, and then this is going to be 5 rad 4. Oh, wait. Sorry, they're not under the same radical, are they? Okay, sorry. I wrote this wrong. Like that. Okay. 2 plus, this is going to be 5 rad 4 plus 5 all over this times this. Oh, wait, but these are 4th roots, not fucking square roots, are they? Oh, man. Nothing. What's up, Rondo? Nothing is rational about this dude, yeah. Okay, whatever. This is the 4th root of... Ugh. How do I want to do this? Huh. That's going to get me the 4th root of 25. Minus 1. Do I got to do it again? I feel like I do. Oh, this is just going to be a messy mess. Okay, because now if I multiply this by the 4th root of 25 plus 1. Dude, what? Dude, Quam, why was this question given to you, dude? Sure. This equals the 5th root of 2 plus the 5th root of the 5 times the quad root of 4 plus 5 quad root of 4 plus 1 quad root of 5, sorry, quad root of 25 plus 1, and then it's this squared minus this squared. So this is cool. So this becomes all over the 4th root of 25 squared, but 25 is the same thing as 5 squared. So it's 5 to the 4th minus 1. And now this goes away, finally. Because the 4th root of 5 to the 4th is just 5. Good. Okay, so this is now the 5th root of 2 plus 5 quad root of 5 plus 5 quad root of 25. What's up, Mondo? Thanks, dude. I'm gonna down the rest of my protein shake. Got some combat crunch today. Today was shoulders and arms. So I did a little bit of triceps, shoulders. I have been looking a little thirsty today, dude. I'm thirsty for the dubs, dude. This is 4 minus 1. Okay, cool. So this is just... No. This is 5 minus 1. This is 4. Okay. And this is somehow equal to the 20th root of A plus the 20th root of B. Why? Why in God's name? Why would someone hurt you like this? This just doesn't seem like a good idea, dude. It's a big pile of shit.
That is one big pile of shit.
Yeah, it is. Yeah, well, that's a really big pile of shit, dude. Okay. Well, we rationalize this at least. I could go through and multiply these things. Not gonna turn out nice. Also, it's the 5th root. Where did this question come from, Quam? This is what I call, like, this is just pain for the sake of pain, you know? It's like BDSM for math. Like, why? I get it. Some people get off to it, like, you know, whatever. But just why? This is not a high school math question. I'm calling bullshit on that. Calling big bullshit on that. No way. You're the high school for fucking geniuses then. It is not an algebra question. Are you serious? That is false. See you, Reki. Yeah, that's not a high school question. Calling cap on that, dude. That's big cap. Two variables and then solve for them? Yeah, that's a little bit different. Yeah, dude, no, we can solve for two. You need two equations first off for there to be to solve for in algebra for two variables. That's a single variable with just something nightmare hard for two constants. That's too cool. They're not constants though. A and B are numbers in that situation. Looking at this question, A and B are numbers. Find a pair of positive rationals. Yeah, they want A and they want B. And they have to be rational numbers for this. This is actually not very bounded, honestly. I think what happened is you typed into Google equation with two variables hard and it gave you this. What is the one solution, Quam? Don't tell me it's the final solution. I know where this goes. I know I'm... You want to tell me the next step, please? Yeah. What's the next Quam? Root of 5 plus 1 to the 5th. Root of what? Root of... Oh, root 5? Wait, what? I don't know what that means as the next step, though. Fourth? Yeah. Yeah, join the Discord, Qualcomm. Fourth root of 5 to the 5th. You're saying this? Fourth root of 5 to the 5th? What does that help me with? Also, I don't know where the 20th root is going to come into play. I agree I want this to be something to the 5th. Because then this would just exit itself out. Okay, so what? You want to say that... Set to the 20th exponent? Okay, alright, well, whatever. Here, let's try this. Okay. 2 plus 5 over the 4th root of 5 minus 1 has to equal some number to the 5th power. Right? Because, I mean, that would be nice, right? I don't... I feel like what you're trying to do here is something with... Just for example, if I have the square root, let's say I have 3 over the square root of x plus 2. I want to multiply this by the square root of x minus 2 because this satisfies an a plus b, a minus b relationship, which then I know will get me an a squared minus b squared. Okay? And that ends up killing the root. That's nice. That's the traditional thing you learn in algebra or even like upper level high school. This is a 4th root. So I'm trying to do something with the 4th power. So I want I think a sum or a difference of cortex. I have it for cubes. That's for cubes. That's cool. Where is there one for 4th powers? Okay. Thank you, Endar. A to the 4th minus b to the 4th. Yes, good. Is equal to a squared minus b squared. A squared plus b squared. Just go to our office hours chat. Don't open that. Don't open on stream. Why do you want me to not show it on stream? That's dangerous. Oh, it has your first and last name. Okay, cool. All right, yeah. I'll take a screenshot of it. Don't worry. Yeah, you can also just DM it to me if you want. Oh, Zach started his Infinite Series stream. Oh man, I really want to go over that. I want to go to that. Damn. Fuck. Never change, Chief. Fire alarm at the Harvard Science Center. Uh-oh. Never change, Chief. Okay, here while you're getting that for me, let me work on someone else's question real quick. I've gotten 2 absolute mindfuck of questions today. All right, Darsh, here, I'll do yours real quick. What's up, Darsh? Are you here? Cool. All right, here. Let's do yours. All right. State the asymptote of this. Okay. Asymptotes occur. So vertical asymptotes occur when dividing by 0. In this case, you can't really divide by 0. There's nothing here to divide by 0. So we're going to say that there are no vertical asymptotes. Okay. Horizontal asymptotes occur when y goes to like a number, when x goes to positive infinity, or x goes to negative infinity. All right. So that's all you really have to do is just plug that in. Okay. So let's try that out, Adarsh. So let's do it. So we have f of x is equal to. I'll look at the solution in a bit, Quam. Just let me help out students who actually need help. I've had 2 students leave now because I keep spending time on seemingly impossible math questions. Is Nightbot a person? Yeah, Nightbot is a person. Okay. This ends up being 4. So infinity minus 3 is the same thing as just infinity. Infinity is a concept. Infinity is a huge number. Okay. So a huge number minus 3 is still a huge number. So you can just write this as 1/2 to the infinity. Okay. And now what we learn, right, is that if something is a fraction and it's going into the infinity power, this is the same thing as infinity, is as 1/2 times 1/2 times 1/2 times 1/2, like on repeat. Okay. And as that happens, this is eventually just going to become to 0. You could also evaluate it this way. 1/2 to the infinity is the same thing as 1 to the infinity, which is just 1, over 2 to the infinity. 2 to the infinity is infinity, because this is the same thing as 2 times 2 times 2 times 2 times 2. Like a ton. Okay? And then anything over infinity, as long as it's not infinity, is going to be 0. This goes away. So if this is 0, 4 times 0, now we have one of our asymptotes. And one of our asymptotes is at f of x is equal to 0. Is an asymptote. as x approaches positive infinity. Now, we're going to be a little tricky here, though, because what would happen as it went to negative infinity? All right, so let's see this. So here we have is equal to 4, and then we have 1/2 to the negative infinity, okay? We should recognize, right? Negative exponents is the same thing as flipping what's inside and making it a positive exponent. So this is the same thing as flipping this. So that's 2/1 to the positive infinity. Now this, 2 to the positive infinity, that's 2 times 2 times 2 a bunch of times, which is infinity. So this does not have an asymptote, right? There's no asymptote here, because this just keeps going. So there's only an asymptote as x goes to positive infinity. I mean, what this probably looks like, something like this, for instance, such that as you go to the right, eventually your point goes to 0 here. But if you go to the left, it just grows up like huge. Yeah. Does that make sense, Adarsh? That's what it is. Cool. All right, nice. Good job.
Well done! Well done!
Yeah, so in general, Adarsh, when you're doing these, you need to plug in positive infinity and plug in negative infinity and see what happens. But then you have to be kind of clever about what the rules are. So here are kind of the rules with infinity, okay? Infinity plus anything is equal to infinity. All right? That includes infinity. Infinity minus infinity is undefined. We don't know what that is. Infinity times infinity is infinity. Anything to the infinity or infinity to the anything is also infinity, unless it's negative. Unless this thing is negative, okay? But 1 over infinity is always equal to 0. If numbers are infinite, does that mean Mondo is actually a number? Yes, Mondo is the world, dude. You're infinite, yeah. Am I missing any other ones here? Oh, this is another thing. Okay, so infinity divided by infinity is also undefined. You don't know what this is. We don't know which one goes to the bigger infinity. I think these are kind of all the infinity rules. It's like the infinity stones or something. But yeah, so once you know those, trust me, that'll help you a lot in trying to do math stuff later. All right, Ace, what's up? Need help with chem? And then Qualm, I'll look at your solution. Did you send it to me? All right, let's do it. I'll do some of these because doing all these would probably take a while. Okay. Oh, is that Animal Farm? That's great. All right. These are, I believe, ionic compounds. His solution looks like an MLA formatted research paper. Yeah. What high school do you go to? Are you catfishing us, Qualm Qualm? Actually, I think Qualm Qualm is like from the Philippines. Not the Philippines, sorry. From Singapore, I believe. It's from somewhere like super smart place. Yeah, Qualm Qualm, where are you from? Okay. Oh, so you need help with this one. This one. All right, 1, 2, 3, and this one. Okay. Anytime you see something kind of grouped together here, that's what's called a polyatomic ion, is what it is. So, for instance, this thing together is called hydroxide. This thing is called sulfate. This is nitrate. I don't know what the fuck this is. This is also nitrate. This is chlorate. This is bromate. Some of them are bromite. Is this iodate? IO3? Dude, you got the jokes, dude. Oh, it is iodate. Okay, cool. That's cool. And it's a -1 charge? Okay, cool. All right. So this PB is lead. This would be lead iodate. However, there's a key little problem here. Lead in the periodic table is in kind of a weird spot. Exactly. Good. Yeah, the Roman numerals. We're gonna get to it. Yeah, the Roman numerals. Good job, Darsh. Yeah, anytime you have something here that is being named, with the exception of certain things, we don't know what the charges on these things are. This is always +1, this is +2, this is +3, this is plus or minus 4, but this is kind of like Mystery Land. So when you see things there and it's kind of, you have to put the Roman numeral because it's ambiguous, okay? And the Roman numeral refers to what the charge is. So, iodate, we saw before, is a -1 charge, all right? And there are 2 of them there. Do you see how there's 2 here? 2 iodates. So that means there's a total of a -2 charge here. So this thing must have a +2 charge, okay? So that's why you would write this is lead 2 iodate. They do, usually, yeah. And all they are is you just take whatever this is and you like put it up there. And that's the charge of it. Right, okay. So for this one, nickel bromate, right? This is going to be nickel what? So bromate, I think by itself is a -1 charge. Pretty sure it is. Bromate's -1. Okay. Bromate's -1. You have 3 of them. That gives you -3 on this side. That means nickel must be a +3. So this is going to be like this. And then for this one, this is copper sulfate. However, they didn't give us a charge for sulfate here. You have to know these ones. So we have to say, like, sulfate charge. Sulfate, yeah, is a -2. I remember that. So sulfate is a -2. So this would end up being copper 2 sulfate. Bromate is your brother sharing a room with you? Not wrong. Yeah. So that's the general thing. Some of these get a little trickier. Especially down here. Like, this is ammonium. You have to recognize this is ammonium. I believe this is acetate. This whole thing. Which is like CH3COOH. Or COO-, sorry. Yeah, acetic acid has the hydrogen on it as well. Yeah, this is acetate. Nitrate. And chlorate. Yeah, not too bad. This is cool, though. I like this stuff. Cool. Good question.
That's dope. Well done. Well done.
Acetate. Screw nomenclature. Yeah, I know. Dude, it's yeah. It's useful because we had to come up with rules for how to name these things. Otherwise, people would be using all sorts of weird pronouns for, like, salt. So, and the naming conventions we use come from this organization called IUPAC, the International Union of Pure and Applied Chemistry. And they kind of write the standards for how you name different compounds, which gets complicated in organic chemistry. And it's a lot, yeah. Okay, cool.
Good job.
Good question. Where was the solution he posted, dude? Okay, I see it. Well, it's okay. No, he wrote it in LaTeX, so this is fine. No. I mean, a lot of publications are written in LaTeX, so that's cool. I understand why you would think it's a publication, but nah, it's just Qualcomm just wrote it up nicely, which is cool. All right, let's see. Let's set x equal to the 4th root of 5, which means x to the 4th is equal to 5. If we take out this from under the 5th root sign, it's easy to rationalize this. We can rationalize this as 5 over x minus 1. Okay, I don't agree with this, though. Why are you multiplying the top and bottom by this? Sorry, what? To make the bottom 5? How? Sorry. X to the 4th is equal to 5. So you're gonna rewrite the 4th root of 5. Okay, so I have 5 over x minus 1. And then you're gonna multiply this by x cubed plus x squared plus x plus 1? Why? Where did this come from? That I'm curious about. It gives x to the 4th minus... Okay, that's what I was asking. I was asking what the quartic is. Because this is similar to if you were doing x minus 1 times x minus 2. Right? To get x... Sorry. X minus 1 times x plus 1. To get x squared minus 1. And if you did... if this was x squared... Like if I wanted x cubed, I guess. That would be x minus 1 times... Oh, how does that one work? Is it x squared plus x plus 1? Is that how that works? Does this give you x to the 3rd minus 1? Is that a general trend, actually? One sec. I want to test that out. Sorry. If I do x plus 1, or in this case it was x minus 1. For x minus 1 it does. Oh, that's cool. So if I do all the powers like x squared plus x plus 1, that simplifies, oh, to the 3rd power. Okay, so if I put another one, I get the 4th power. Oh, wow. Why? Oh, I see. Because you're getting the next power up with the x, and then you're losing that same power with the minus 1. That's very clever. That is not an algebra trick. I mean, what is an algebra trick? But that's not something you learn in high school. I see. Okay, because moving this through, right? This is almost like a telescoping series. You get x to the 3rd plus x squared plus x, and then you get minus x squared minus x minus 1. These all go away. Oh. You actually use that trick for showing the geometric series formula. That's fucking cool. This is high school? This is not high school. I beg to differ. I don't know what fucking high school you go to, but this is not regular high school. It is Asian high school? That makes sense. Okay. All right. Makes sense if it's Asian high school. This is not U.S. high school. Anyways, cool. Yeah, you are right, Qualcomm. It is kind of what I was trying to do here. The issue is that this was going to become a mess. And I like, yeah, this simplification here, calling it x, probably does make things easier. Right? Because this was the 4th root of x squared, right? Okay, whatever. So, blah, 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 blah.
Nice.
So, what's up, Jerry?
My man.
Okay, so then you get to here. To be able to take the fifth root of the denominator, we must factor. And they say this looks like x plus 1 to the fifth? No. 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 Absolutely not. Oh my god. Jerry, this is apparently a high school math question. This is a question that this student got in their high school. This. Oh my god, dude, what? First of all, no one knows the binomial expansion of x plus 1 to the fifth. You just don't. I don't even know that. Well, it's simple when you have the answer. Of course it is. This value is just twice the denominator, so we just... Okay, cool. Then you take the fifth root of that, which is that. For our final step, we can separate the two terms and set them equal to the... Okay, so... So our final answer is this. It's cool. You know, I'll give you credit, Quam, because it is a legitimate solution. I thought at first you were just giving me... Because people have done this to me before, where they just give me some ridiculous, recalculous, non-solvable math question to do. But this is solvable. So I appreciate that there is a solution. But would I have gotten to this on my own? I mean, I tried to get to this. I got kind of close to here. I would not have recognized the fifth power binomial expansion. I wouldn't have. And I don't think anyone's expected to. If I'd seen... I mean, I don't even know the third one, really. It's Pascal's triangle. You're right. It's like 1, 3, 3, 1, right? It's 1, 2, 1, 1, 3, 3, 1, and then 1, 5 fucking something. Yeah, 5, 10... Anyways, alright, whatever. I should have expanded the top. Yeah. Quam, you're right. And that's exactly what I should have done here. But I would not have seen x plus 1 to the fifth. I wouldn't have seen it. Because that's what you have to do in order to get this to then cancel with this. You have to show that this whole thing is something to the fifth power. Yeah. Hey, it's cool. Whatever. It's a good question. I like it.
That's dope. Well done.
Okay. Cool. With that, let's end out the stream. All right. Thank you, everyone, for coming to office hours today. Had a fun time working with you guys. Thanks for the challenge questions. I know I get frustrated at times because I'm used to teaching just regular high school and college stuff. These math challenge questions tend to test my patience sometimes. Can I have 2 free points so I can cash out? No. No. No begging. What am I like? Okay, good question. Yeah. So, Jerry, I know Quam, but it's not American high school. Go way well off. So, if you ever want to figure out... So Jerry, thanks for asking... Thanks for finding us and following us. That's cool. We have a whole other conglomerate of math streamers on Twitch. So that's all their Twitches. And then here, if you go to our website, we have a Google Calendar that updates in real time that shows when people are streaming. So we're going to go raid Zach right now. I think you regret saying this was a bit of a softball. I do, Shantrix. Yeah. Make him a little bit. Yeah, let's course correct. Yeah. The last one was a softball. This was too much of a hard ball, so let's come back down. Can I... Yeah, so the link is there. If you type in !cal, there's the link. It's calendar.actual.education. That'll take you here to our Google Calendar, and that's when everyone is streaming. So you can go check them out. Okay, so with that being said... we're going to go raid Zach. He's doing a math stream on Infinite Series right now, which is really cool. If you have any other questions about math or science, please join our Discord. It's right there. That's it. And you can post screenshots of what you want to go over, and we'll do it on tomorrow's stream, which will be at 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. There's the Discord. Exactly. That's how to join the Discord. Yeah, of course, Jerry. No, you're welcome. Yeah, we're a nonprofit. We help kids and whatever with like math and science. Yeah, that's what we do. All right, cool. All right, let's see. Let's go raid Zach. He just started his thing. It looks on Fractions and Infinite Series. We'll go say hi to him. Otherwise, yes. Have a wonderful rest of your Tuesday. Great start to the week. And we will see you tomorrow. Peace out.
Not the sequence, right? Like, I think the sequence will uniformly converge for sure. But since we're interested in series,